Radioactive Half-Life. We know that radioactive decay is a random process. For every second, there is a probability that a nucleus will decay, which is called the decay constant and given the symbol lambda. If you have a sample of the nuclei, the probability of decay will determine the fraction of the sample that will decay. Of course, if the sample is larger, then more nuclei will decay in each second. This means that the activity, the number decaying per second, is proportional to the number of nuclei in the sample n. Mathematically, we write this as h equals to minus lambda n and dn over dt which equal to minus lambda n. There is a minus sign in the formula because the number of nuclei in the sample decreases with there in time, but in practice we ignore the minus sign when we use the formula. The units for activity are becquerel. Worked example 8.11. What's the activity of a sample of 100 million atoms of carbon-14? The decay constant lambda is 3.84 times 10 to the power of minus 12 second inverse. dn over dt in the units becquerel. The lambda in the second inverse, 3.84 times 10 to the power of minus 12 second inverse, and 100 times 10 to the power of 6 atoms. Use dn over dt which is equal to minus lambda n, 3.84 times 10 to the power of minus 12 times 100 times 10 to the power of 6, which equals to 3.84 times 10 to the power of minus 4 becquerel.